I get the sense that everybody's getting out of the gene business and suddenly going into this new business I hear about called the protein business. There's even a new name. Instead of the genome, I'm hearing this other name,
The proteome.
The proteome.
Yes.
What is that?
Well, the genome is the collection of all your genes and DNA. The proteome is the collection of all your proteins. See, what's happening is we're realizing that if we wanted to understand life, we had to start systematically at the bottom and get all the building blocks. The first building blocks are the DNA letters. From them, we can infer the genes. From the genes, we can infer the protein products that they make that do all the work of your cell. Then we've got to understand what each of those proteins does, what its shape is, how they interact with each other, and how they make kind of circuits and connections with each other. So in some sense, this is just the beginning of a very comprehensive, systematic program to understand all the components and how they all connect with each other.
All the components and how they connect. But how many components are there? How many genes and how many proteins do we have?
A real shock about the genome sequence was that we have so many fewer genes than we've been teaching our students. The official textbook answer is the human has 100,000 genes. Everybody's known that since the early 1980s. The only problem is it's not true. It turns out we only have 30,000 or so genes.
30,000 genes? That's it? Not everybody agrees with this number, but that's about as many as a mouse. Even a fruit fly has 14,000 genes.
That's really bothersome to many people, that we only have about twice as many genes as a fruit fly, because we really like to think of ourselves as a lot more than twice as complex.
Well, don't you?
I certainly like to think of myself that way. And so it raises two questions. Are we really more complex?
You show me the fruit fly that can compose like Mozart, and then I'll,
Yeah, well, show me the human that can fly, right? So, we all have our talents, right?
I suppose we do, but as it happens, we have lots of genes that are virtually identical in us and fruit flies. But happily, our genes seem to do more. So let's say that I am a fruit fly. One of my fruit fly genes may make one and two slightly different proteins. But now I'm a human, and the very same gene in me might make 1, 2, 3, 4 different proteins, and then these 4 proteins could combine and build even bigger and more proteins.
Turns out that the gene makes a message, but the message can be spliced up in different ways. And so a gene might make 3 proteins or 4 proteins, and then that protein can get modified. There could be other proteins that stick some phosphate group on it, or 2 phosphates groups. And in fact, all of these modifications to the proteins could make them function differently. So while you might only have, say, 30,000 genes, you could have 100,000 distinct proteins, and when you're done putting all the different modifications on them, there might be 1 million of them. Scary thought.
So starting with the same raw ingredients, the fruit fly goes, but the human, by somehow or other being able to arrange all the parts in many different ways, can produce melodies, perhaps.
Yes, although we're not that good at hearing the melodies yet. One of the exciting things about reading the genome sequence now is we're getting a glimpse at that complexity of the parts and how it's a symphony rather than a simple tune. But it's not that easy to just read the sheet music there and hear the symphony that's coming out of it.
Okay, so it's not just the number of genes, it's all the different proteins they can make and then the way those proteins interact. And to figure out all those interactions and how they affect health and disease, that's going to keep scientists very busy for the next few decades. But of course, before the research can begin in earnest, they first have to complete the parts list, all the genes. And by the spring of 2000, both sides, the public labs and Celera, they were in hyperdrive, each camp madly trying to be the first to reach the finish line and get all 3 billion letters.
The pace of things and the magnitude of things was really incredible. I mean, I would remember coming in and just having this really gripping feeling in my gut, just an intense kind of, oh my God, am I up to this?
You know, whoever has this reference sequence of the human genome out there in the world first, they're going to be famous. They're going to be on the front page of the New York Times and a lot more than that. For a long time, they're going to be, celebrities. And, when that's going on, it's not unreasonable that people are going to reach for that star and try to get there before the other person.
I thought that the really intense competition in this world were among businesses where there was a profit motive. I now find that we are pikers in the business world compared to the academic competition that exists out there. And I'm beginning to understand why, because their currency is publication. Their currency is attribution. And their next funding comes from their last victory.
I think we're all better off for the fact that there is this competition. What you want is a system that gets people riled up and try to do something faster, better, and cheaper than the next guy.
The environment at Solaris was extremely intense, and it reminded me of Finals Week at Caltech. And there's a tradition at Caltech that on the very first day of Finals Week, the Ride of the Valkyries is played at full blast. And so I thought, well, since every week feels like it's Finals Week here, why don't I play the ride and see what happens? So we got a whole bunch of Viking hats, and we end up buying Nerf bows, okay, because we're Nordic Valkyrians. So the next week we're shooting each other. We go, there's something not right about this. So we decided the next week that we'd start doing raiding parties and raid some of the other teams. Unbeknownst to us, they had been preparing themselves.
Hey, you guys go to the back stairs?
They had little beanie hats, okay, and their own Nerf weapons. Then the war started. It's just a release. It's a way of kind of dealing with the pressure, I think. We all ran around like crazy for 5 or 10 minutes and, got a little physical exercise. And had a few laughs, and then we're ready to really go after it.
The Wagner seems to be working. Output at Solera continues at a relentless pace.
If you have problems, call us back, okay?
Venter insists that the urgency stems not only from a desire to beat the government project, but the firm belief that what's coming out of these machines, all the A's and C's and T's and G's, will have a profound impact on all our lives.
It's a new beginning in science. And until we get all that data, that can't really take place. I mean, anybody that has cancer, anybody that has a family member with a serious disease, this data and information offers them tremendous hope that things could change in the future.
In the past, if you wanted to explain diabetes, you always had to scratch your head and say, well, it might be something else we've never seen before. But knowing that you've got the full parts list radically changes biomedical research, because you can't wave your hands and say it might be something else. There is no something else.